Frequency is the number of cycles that the function completes in 1 unit interval. So you will be asked to calculate the frequency from time to time. So here is your definition, and if you're asked to actually calculate it, the frequency is the reciprocal of the period. So frequency is equal to 1 over the period. So some review of notation when we're graphing. We have A, which is always positive, and that's our amplitude. We have 2 pi over B, and that is our period. Now we have 1 over our period, which is our frequency. We have what we call a sinusoidal axis. That is the midline of the graph, and it occurs when we have a vertical translation up or down. So our sinusoidal axis is y is equal to d, where d is that translation up or down. And then we also are introducing a phase shift, and that is our horizontal translation. And we find that by taking what's inside the parentheses, setting it equal to 0, and solving for x. So when we're graphing, we need to find the period and the critical points. We need to identify the phase shift. We have to find the axis, which is that d value, the sinusoidal axis, the amplitude, the scale, and then we always want to label, and especially our starting position of our graph. So in the question below, we have our A value, which is our amplitude, which is going to be 2. Our period is 2 pi divided by b, and our b value is 1, so our period is just 2 pi. Our critical points, we take that period and we divide it by 4. So 2 pi divided by 4 is pi over 2. So every horizontal distance of pi over 2, we have a critical point. And our phase shift, we take what's inside the parentheses, which is x plus pi, we set it equal to 0. Because it's negative, that means that our graph is going to shift to the left by pi. There's nothing added or subtracted, so no d value, so that means that the axis, so the midline, is going to be y is equal to 0. And then we also need our scale, and we're going to make our scale pi over 4, because that multiplies into pi over 2 as well as the period. So let's draw our xy plane. So here's our xy plane. I'm going to do my scale of pi over 4, so each grid point is pi over 4, so every 2 is going to be pi over 2. So I have my scale on there. My amplitude goes as high as 2, so I'm just going to do a dashed line here so I can kind of create some boundaries of where I'm going to draw my graph. And the y-axis has not been shifted up or down, so that means that that is my midline. Now because I'm drawing a sine graph, sine usually starts at 0, 0, it goes up and then down, and that is 1 period. this point that normally is on the origin has been shifted to the left by pi. So that's going to be my starting position. So it's still on the midline, but instead of being at 0, 0, it is now moved to the left by pi. The next point, or critical value, is a maximum. So I'm referring to my little diagram up here of the parent function of sine. So my next point is going to be a maximum, and it is a distance of pi over 2 from the starting point. So there's my maximum, and it's a distance of pi over 2. Then my next point is back on the midline, and again it's a distance of pi over 2. My next point is a minimum, and it is a distance of pi over 2. My next point is back on the midline, and it's a distance of pi over 2. So you'll notice that there's a distance of 2 units between each critical point. So I'm going to draw my graph. And I can continue it as well and do another period. It's just following a pattern. So every 2, we go maximum, then midline, then minimum. We can do that in both directions if we need to. Put some arrows on here because it does continue. And that is our graph that has been shifted with a phase shift to the left by pi.